Okay, hello everyone. So Math 110 is back. We're continuing from where we left off in class before, Cuomo decided he was going to close CUNY. All right, so let's talk about and and or probability. So if we are told to find the probability of like A and B, two events, right, the notation for that would be written like this: probability of A and B. So if you see A and B together next to each other like that, it means A and B. And what this means is that A and B both need to happen for success. Okay, so both A and B have to happen in order for the event to be considered successful. Now, with or, the meaning of or in math is slightly different from how we use it in conventional English. So if we're talking about probability of an event A or an event B happening, what this means is that A or B, or both A and B, must happen for success. Okay, and now in normal English, when we talk about what the word or means, is usually we just mean A or B. So let's say you're out at a catered dinner or something like that, and you have a choice of dessert, and the waiter comes up to you and they ask you, okay, do you want the chocolate ice cream or do you want the vanilla ice cream? Normal people who aren't familiar with the math meaning of or will pick one of the two flavors. Now that you know in math or can mean both, you can just say yes in response to that. Okay, so now let's look at an example that is going to illustrate what we were talking about here. Okay, so let's say we have a regular 52 card deck of playing cards, and we're going to take one card out of the deck at random. We want to determine what the probability is that the card is first going to be a jack and a spade. So going by the definition we had before, the card has to be both a jack and a spade. It's not enough if it's only one without also being the other. And then we'll look at the probability of getting a card that's a jack or a spade. So if we want to find a card that's a jack and a spade, right, it has to meet both of these conditions, right? So here, I have a bunch of spades, right? And I also have a bunch of jacks over here, right? But the only one that actually is both a jack and a spade is this one, the jack of spades. And there's only one card in the whole deck that meets this requirement. So our probability here would be 1 out of 52 because we only have one card that meets this requirement. Now, if we're looking at the probability of a card being a jack or a spade, right, this would qualify, right? Because this card is a jack. It's not a spade, but it's still a jack, so it meets that requirement, as would, all of these other jacks. As long as they're jacks, it's good. And if we look at some of these other spades we have here, right, well, this would work because it's a spade even though it's not a jack. And this would also work because, okay, it's a spade even though it's not a jack. So if we want to count how many cards we have over here, right, we have these 4 jacks. And then we have, right, how many spades? And then we have an additional 12 spades over here, right? So that would give us 16 out of 52 if we add those together. Right, but let's look at another way we could, figure this out, because we're not always going to have, a deck of cards with you. You might have other types of problems where you can't, reason out everything, that you're working with. So, right, let's look at another way we could do this. So we know that we have 4 jacks. And we know that there are 13 spades in the deck. Right, but if we add 4 and 13 together, we're going to end up getting 17. We're not going to end up getting 16. So why does that happen? Well, if we look at what we have over here, right, here we have our jacks, and this card is both a jack and a spade. So our jack of spades is going to be counted in this group of jacks, and it's also going to be counted in this group of spades. So we don't want this card to be counted twice because it only shows up once in the deck. So we would subtract the card that shows up in both categories. And then if we do that, we end up getting 16 out of 52, which is the correct probability. And that brings us to something called, let's see, where is my other paper? Okay, that brings us to something over here called the addition rule. Okay, so this brings us to the addition rule. Now, this is something that we can use when we're dealing with probability problems that are asking us to find the probability of an event A or B. So the way we do this is we add the probability of event A, add it to the probability of B happening, and then subtract the probability that both happen. So probability of A and B happening together, like what we saw over here. Yeah, so this is what we did over here. Okay, now let's take a look at another version or another situation we could be looking at with this deck of cards. Another interesting and an or probability question. Okay, so now let's say we are going to, again, randomly select. Okay, so now let's say we're going to again randomly select one card from a regular deck of 52 cards, and we want to find now the probability that the card is going to be a jack or a queen, and then we want to find the probability that the card will be a jack and a queen. Okay, so if we want to do a card that's a jack or a queen, right, we can look at that similarly to how we looked at it before, right? So we know, okay, well, we have 4 jacks in the deck, and then we also have 4 queens in the deck. Right, we also have 4 queens over here, and this is it. These are the only cards in the deck that are either jacks or queens or anything related to those. So, right, we can also use our addition rule over here again. Right, so if we apply the addition rule, right, probability of getting a jack plus probability of getting a queen, and then what are we going to do? Subtract the probability of getting a jack and a queen. And I presented these questions in the wrong order. All right, so we'll talk about D when we're doing this one. Okay, so probability that we're going to get a jack is 4 out of 52. And we also know probability of getting a queen is 4 out of 52. And then now, okay, well, we ended up looking at part D over here because we did the addition rule. But we don't have any card that's both a jack and a queen at the same time, right? We can have a card that's a jack or a queen, but both at the same time isn't going to happen, right? So this is just 0 out of 52. So we just end up with 8 out of 52. And now when we get over here, we want to find the probability of a card being either a jack or, right here, jack and a queen at the same time, right? No such card exists. So, you know, like we saw up here, our probability is going to be 0 out of 52. And that brings us to a definition, right? So the reason, right, we can't get them at the same time is you just can't have a card that's both a jack and a queen. So here, this is an example of mutually exclusive events. So mutually exclusive events are 2 or more events that cannot happen simultaneously or at the same time. In conventional English, we can also use the term mutually exclusive to talk about 2 things that can't be done at the same time. Although usually you would see people talking more about things that aren't mutually exclusive. let's say, you're protesting anything, there's going to be somebody who asks you, why don't you care about this thing instead? I think this is a better thing for you to protest. Or they may say, why don't you have a job or something better to do? You can respond that those things aren't mutually exclusive, because you can care about more than one cause and protest more than one cause, or because, yes, you can have a job and you can also protest things. Let's take a look at another example now. Let's say that we have a bag that contains 10 black marbles, and each marble has a number between 1 and 10 written on it, or all the numbers 1 through 10 are written on the marbles. And then we have 8 blue marbles, and they're labeled with the numbers 1 through 8. Now we're going to take one marble out of the bag at random, and we want to find the probability first that it's blue, then that it's blue or number 3, and then that it's blue and marked number 3. So you can pause the video now and you can try this yourself, and then I'll go through and show you what the solution to the problem is. Okay, so first, to give us a better idea of, what we're dealing with, we know that we have 10 black marbles, so I'll draw them out over here. That's 5, 6, 7, 8, 9, 10. And these guys are all labeled 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we have 8 blue marbles, 3. Right, so then we have 8 blue marbles, and, these guys are also going to be numbered. Well, I drew them a little bit too small, but these guys will also be 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we'll just say, just to clarify, these guys are supposed to be blue, and these guys are supposed to be black. Well, they are drawn in black, but this is more purple than blue. Okay, or maybe it looks blue to you guys, or it looks black. So anyway, all right, so if it's blue, we know that, okay, we have 10 black marbles and 8 blue marbles, so we have a total of 18 marbles. Right. Okay, so 18 is the total number of marbles we have, so any probabilities we have for picking one marble is going to be out of 18. And now if we just look at how many blue marbles we have, there's 8 of them, so our probability here is going to be 8 out of 18. Okay, so now let's look at part B, where we want to see is the... Now let's look at part B and find the probability of a marble being either blue or numbered 3. Okay, so, right, if we use our addition rule, that's going to be the probability of getting a blue marble plus the probability of getting a marble number 3 minus the probability that it's blue and number 3. Okay, so probability of a blue marble we know is 8 out of 18. Now, probability that the marble is numbered 3, right? This is still going to be out of 18 because we still have 18 marbles to choose from. Well, we only have 2 of them that are marked 3. So there's only 2 such marbles. Now, if we look at a marble that's both blue and number 3, right, that's only going to be this one up here, right? So this guy's blue and 3, so we would subtract this one. And this is going to be, let's see, 8 plus 2 is 10, so this is going to end up being 9 out of 18. Okay. All right, so now if we want to find a marble that's both blue and number 3, well, it was just this one that we had over here, right? We ended up answering this part of the question over here.